Hey everyone, welcome to today's episode of DevSlop. I'm your host Shri, here with my co-host Nikki.
Hey everyone. Hey Shri.
Hey Nikki. We have a great show planned for you today, but first, a quick message from our sponsor for today's episode, Datadog.
Datadog's cloud security platform detects threats in real time across your full stream of ingested data. You can easily get started with default detection rules that map to the MITRE ATT&CK framework and other compliance standards. For more flexibility, you can write custom rules right in the UI, no query language required. The cloud security platform also tracks your compliance posture alongside other security threats. And expert-built dashboards offer immediate visibility into threats and trends. 500 plus out-of-the-box integrations give you security insights in minutes. You can now view and correlate all your data in a unified platform that brings together DevOps and security teams. Sign up for a free trial of Datadog today and receive free swag.
All right, well, I'm super excited to be talking about microservices, how to manage cloud apps, and why it is so hard, despite all of our efforts to make things work. Nikki, do you want to introduce our guest?
Sure. Today's guest, Or WEIS. Or is the CEO and co-founder of Permit.io. He's a co-maintainer and author of the open source tool OPAL.ac. Or is a serial entrepreneur who is passionate about developer tools, previously founded Rookout.com, a leading production debugging solution, and manages Upwards, Israel's largest founders community. Before becoming a founder himself, Or worked as a lead engineer in multiple cybersecurity big data companies. Welcome to the OWASP DevSlop show, Or.
Hi, Nikki. Hi, Shri. It's a pleasure to be here. Really excited to talk with you folks.
Cool. What do you got for us today?
So we're going to talk about modern access control in cloud applications. We're going to talk, as Shri said, about how difficult it is, why it is difficult, and how it's affecting the way we're building products. And more importantly, how we can make this easy by leveraging the right open source solutions and best practices, so we can actually go on focusing on actually building our products, not worrying about access control all day.
All right, let's get the deck up.
Let's get started. So let's just rewind this quickly. So we're getting quick spoilers. Okay, so my name is Or WEIS. We kind of covered my background. I'm the founder of Permit.io. My background starts as far back as the intelligence corps in the IDF, and I'm really passionate about both developer tools and security. So this is really kind of my sweet spot. Let's begin by talking about access control and understanding why it is hard. So things have been changing dramatically in the way we've been building applications. Obviously, we moved to the cloud, but more importantly, we moved into microservices. So the infrastructure we're working with has really kind of exploded. And if in the past, like if you were building like a simple Java application, we could use something like Spring Framework, or for Python application, we could use Django. We'd have some access control kind of baked in, and that would cover all of our needs. But with microservices now, we need a bit of access control in every service that we're building. And there is no one-stop shop that we can just use as a framework and get covered out of the languages themselves. In addition, most of our data plane moved from the database of our application to third-party services. For example, our billing is managed by a different application. Identity is managed by a different application. Authentication is by a different application. And we've got marketing tools and Salesforce management and Workday and a bunch of stuff. And we need all of them as kind of a deep part of every application we're building. So our data layer is spread throughout not just our cloud, but throughout the entire cloud. And that's even before we start to talk about device at edge. If you're running an application that's actually working in the physical world, that there's even more ground to cover. So infrastructure has exploded. That's part one of why this is hard. Second part is our demands or expectations from our policies and applications we're building has also moved up. If in the past, we could just work with something basic like RBAC, or maybe some limited version of RBAC, relationship-based access control, or role-based access control. Those days are gone. We now need to constantly shift between models. There are constantly more requirements coming, both from inside our organization, our customers, constantly asking for more roles and more tweaks to how they can access this solution. And also there are a lot of attributes. So most companies at some point find themselves moving into attribute-based access control. So we all start with, let's just have admin and not admin. We evolve into RBAC, then we moved into more advanced RBAC, but it's constantly increasing. It's never going to stop, and we need to be aware of all the complexities that brings in. So we can't just also settle for a simple solution. We need something that can scale with our demands through time, and that also means complex roles and combining a lot of data sources. We need to control, we need to be able to know where users are connecting from geolocation. We need to know if they paid or not. We need to know what part of the organization do they belong to, and these are just simple attributes.
Real quick, Or.
Yeah.
Real quick. So you're describing this problem statement. We have microservices everywhere, and we have data everywhere, and we need to develop an access control model. So a lot of cloud providers give us these tools to help us do this, right? There's explicit IAM policies you could author. You could designate time-based access to certain things. Are you talking at that layer, or you're talking at the application layer above the infrastructure, or you're talking both layers?
So I'm talking on both layers, but mostly about the application, because when you're building a product, in the end of the day, you need something unique for your application. So if you're building something, for example, a legal solution for lawyers, you can't really settle just for the logics and roles that you have in your underlying IAM. That will be difficult by itself. And actually, it will be a very bad idea because you'll be coupling your infrastructure to your logical layer. And as either your infrastructure shifts, you move to another cloud vendor, or you use different solutions in that cloud, or your application changes its demands or behavior, you'll have a really bad time refactoring everything. So we kind of need a way to be able to leverage the IAM we're getting from the lower layers. And by the way, it's not just the cloud infrastructure. We need access control on physical layers, right? We need to have locks on doors, and we need firewalls and zero trust networks, and we need infrastructure level access control, which service can talk to which service. And this continues to grow up to the application layer. And so we need to see how we can leverage those, but also tailor something for our applications without being too dependent on what's happening underneath.
All right, makes sense to me.
Cool. So let's continue. So we talked about infrastructure, we talked about the policies or permissions themselves, and lastly, it's about security and compliance as a whole. So I don't know if you've noticed, but working for the tiniest startup today, if you're doing B2B or B2D, it's like a matter of months before you need to start working on your SOC 2 or your ISO, let alone FedRAMP and other demands like that. And we also have got GDPR and CCPA regulation, and standards that we need to meet are constantly both increasing in amount and in the height of the standard itself. So we need to have this covered really early on, and we need to cover this end to end. So if we're just throwing in something very simple for access control, it probably won't cover the needs here. And it's actually important to understand that when you look at compliance, for example, when you look at SOC 2 or you look at ISO, about 70%, 80% of the requirements there are all about having processes around access control. How do you mitigate or control who can access the data, who can access the databases, who can access the infrastructure? So by having good access control built both into your customer-facing applications and into your back office and infrastructure, and everything managed in a clear, ideally unified way, you can actually meet your compliance needs more easily. And if you don't, well, it's the other way around. It'll be a lot harder. So this is why access control is hard. But it's not just hard, it's actually broken. From this recent OWASP top 10, access control is the A1 most critical item on the list with the most occurrences. So bad access control doesn't just create bad experiences and difficulty to deliver products, it also creates security issues. It's really hard to get this right, especially if you're building from scratch. If you're reinventing the wheel, because this rabbit hole goes so deeply and keeps growing deeper, you're most likely you most likely end up with pitfalls and gaps in what you've built, and those will translate into security flaws and vulnerabilities. So we really want to be aware of what are our options and how we can avoid those pitfalls. Before we go into the actual solutions themselves, and I really want to be practical, I want to give you, each of one of you listening to this talk, I want to give you actionable items that you can work with when you're upgrading your solution and when you're creating your next one. But let's start with setting the mindset. First of all, access control or permissions can't be an afterthought. And the problem is there often are. When you're building a product, you want to focus on building your product, not on making sure it's all tightened up security-wise, at least not initially. But I'm sorry to say we don't have that privilege. If we end up just sprinkling authorization or access control on top later, we'll most likely fail in building it correctly. So we need to recognize this in the beginning, not necessarily build everything from the beginning, but we need to prepare ourselves in the process of how we're going to grow this and set up the groundwork so we won't have to go back to scratch every time. And the other end of it is it's not something that you can do once and get it over. You are never done with this. They're constantly, and I can tell you this as someone in my previous company, I ended up rebuilding access control 5 times. And in the fifth time I did this, I was like, this is probably 4 times, if not 5 times too many. So we need to understand that more demands are constantly coming from security, compliance, and from our customers, and also internally from sales, professional services, product. So we need to be prepared for that mentally and also have processes in place and a technological stack that can support that ongoing development. And if I mentioned product, in the end of the day, accessing your product and controlling who can access it is probably one of the most critical experiences you have. It's the doorway to your product. So if you don't get this right, a lot of things are going to be painful. So we need to think of this also as part of an experience we're delivering, not just a checkbox we're ticking. Moving from this, we need to also think about the overall space that we're doing. So we kind of mentioned IAM as kind of a bigger scheme and connecting to it in your underlying infrastructure. We need to also recognize the different tiers that we have here. So we have identity management. That's like solutions like Okta and Azure Active Directory, just managing your identities on the side of the organization. Then we move into the products. That's where authentication comes in with solutions like Auth0, OneLogin, Incognito on AWS. That's identifying who's at the door and deciding if we are letting them in. And then we actually move into permissions and access control and the access control itself. And that's about who can do what and when in which context. And we want all of this to connect seamlessly. We don't want each layer to work separately. And thankfully, there are already standards that we can adopt. So these standards between identity management and authentication are pretty mature. We've got SAML and OpenID Connect there, allowing the authentication provider to verify things according to what's going on in the identity management of the customer. So it's important to realize, so we have authentication on the product side and the vendor side, working with identity management on the customer side. And then we also have authorization, working with the authentication vendor side. And through that, mainly through JSON Web Tokens, and specifically through the claims in the JSON Web Tokens, with the identity management on the organization side. So we want everything to kind of trickle down from the top of funnel in the organization into us as a vendor or application provider, and leverage those layers that are coming before and bake that into our product. And these standards are beginning to mature. Nowadays, JSON Web Tokens are a battle-tested solution with good cryptography that we can leverage and start building our authorization on top. But we need to realize it's not authorization by itself. Just a JSON Web Token, it's a start of authorization, but there's still a lot of either code to write or solutions to adopt. Nikki, I saw that you probably want to ask something.
Well, just you're talking about the authentication authorization experience to customers, and in your flow chart there was Okta, Azure AD, OneLogin, Auth0. Where does the customer's experience start in this flow? I guess versus the employee's experience. Just trying to really understand like how, because what I'm sensing is we're trying to construct an access control model that essentially fits all of these use cases, customer, employees, right, to access products, right, from different roles. And I'm just trying to understand how the entry points work here.
Yeah. So for the end user, the experience starts with the identity management in their organization. The problem with that is, as a vendor or application provider, most likely you don't have control of that. But what you can do is you can leverage that through your authentication and authorization, and you can provide the organizations working with you tools to connect their identity management and synchronize it with what you're providing. So, and here it's really about what is the experience that you're building for your product. So let's say you're building a legal application for lawyers, just as an example. So you'd want something like the CFO in that organization. He doesn't get a classic role in the application. He gets kind of an auditor or a reviewer. The partners at the law firm, they get admin rights. And the associates, they get a viewer role or maybe a participant role. So there's a translation from organizational behavior, organizational roles, into actual logic that is specific to the application. And the more we focus on our user experience, the more we know our users, and we leverage these technologies to kind of do that translation, the better their experience would be. And we also need to think about, with authentication, we need to think about how they're going to connect. Are they going to use this on mobile? Are they going to be logging in with their SSO? Are they going to be using MFA? There are a lot of elements there too. And that space is also still evolving with passwordless and new things. But there are even more things in the permission set. So who can allow who to do what? How can we invite our users? How about a lot of patterns that repeat themselves in applications? So approval flows. How can one user ask permissions from another? How can one user invite another user into the application? Impersonation, that's very common for professional services, support, sales, even marketing. How can I view the application that I'm providing, that I'm managing, as if I'm a user, but without actually logging as them? So logging as your user, that's definitely a bad idea. That's not secure. But an impersonation feature can give you the semblance of logging like your users and seeing how they're experiencing your system. And that could be critical for actually having empathy and actually delivering a good solution. And we can talk for hours just about this, but we have a few more things to cover. So maybe we'll circle back.
Sure.
So, or a quick question from
Sure.
Oh, I think we're going to wait. I do have a question from the audience, but I feel like you probably have some more things to touch on, and then we can get to the question.
Sure. I'll happy to go with your flow. So now when we kind of covered the problem space, understood where we kind of connect the difference between authorization or permissions and authentication. Now let's talk about when we go into permissions, how can we make sure that we build this right? And more importantly, how we can make sure that we don't have to constantly rebuild this over and over like I did in my previous company. So there are 5 points here. They are actually prioritized. And if you take anything, take the first 2. But let's start reviewing them, and we'll dive into it. So the first thing is when people are building access control, the most kind of naive approach is to just bake it into the code. It translates into a lot of if conditions. And the problem is it's really hard to differentiate then between application logic and authorization logic. And we already kind of covered there. The two are constantly drifting away. There are different demands coming from security and compliance and customers for authorization and for the development of the application itself. If we keep everything in the code as is, as the application evolves, and it will evolve, we will have to refactor things dramatically. When we come in to upgrade our access control, when we want to move to a different permissions model from RBAC to REBAC or ABAC, we'll find ourselves having to throw everything away, refactoring huge amounts of code, on average taking 8 months of 3 people. And it's just gonna be painful. Instead, what we can do is we can decouple this at the get-go. Essentially create a separate microservice for authorization, and the other microservices would query it with authorization queries. By doing so, we'll be able to scale the things in an independent fashion, and we'll also be able to gradually evolve this. So that decoupled microservice at the beginning could just return true. Whatever you query it, just say, yeah, you're allowed to do that. But then we can evolve it and we can write some baked-in code, and then we can actually adopt a full-blown policy engine. We'll see a couple in a minute. And that can gradually allow us to improve it more and more and more. And every time we upgrade, we don't need to change the application itself. So while we don't have to build it from day one, everything, we don't need to have the best authorization solution in place, but it's not necessarily a bad idea to have it. By decoupling things, we can enable ourselves to have it when we need it. So that's one of the most important best practices here. And in a minute, we'll talk on how we can achieve that with open source. 2, we kind of already mentioned that our applications are exploding out. Most of the data is no longer in our cloud or even in our application, in our cloud or VPC. It's elsewhere. It's third-party applications we're dependent on. I'll give an example. Let's say we want a policy like only users that have paid for a feature can use it. That bit of information now resides in something like Stripe or Chargebees or PayPal. So if we want that as part of our policy, if we poll or wait for that update to come in, it will deliver at best, a bad experience, and at worst, provide inconsistencies that will ruin our security model, because we've added a user or revoked their access, but it takes time for that to update. So we want to build our authorization layer, our permissions, in an event-driven fashion. We have events coming in from all over the place, from our code contributions, from our data sources, from our customers, and we want to be able to feed those in a real-time fashion into the system and update what's going on accordingly. So again, that's something that we don't have to build end-to-end from day one, but we want to structure everything to support that from day one. And and we also see in open source how we can connect this to other event-driven solutions like Kafka and other data sources as well. The next 2 best practices are about the interfaces themselves. And there are basically 2 cohorts that we need to kind of cater to: our customers and ourselves as application developers or providers. In the end of the day, we need to realize that all these people on both sides, they need experiences to manage this in a way that matches what they want. Some of them want UI interfaces, some of them want APIs, some of them want UIs. And we need to be able to layer those in a modular fashion on top of our authorization layer. So again, we don't need to build those UIs and APIs from day one, but we want to have everything set in place so we can add them. We want to build this in a modular fashion to support this. Let's talk a bit about these interfaces, what they look like. So we mentioned a couple, but let's add a few more. So for our customers, even basic stuff like user management and the ability to assign roles. It's really rare to find an application today that doesn't need to add that at some point. So it's probably better to already recognize it now and prepare for it instead of being surprised, oh, we actually need roles and we need a UI for that. On the back office, you need basically everything that you provide to your customers, but instead of just viewing it per tenant, you need to be able to see it for across the system. So you'll need to be able to kind of bring in all your data sources and view them in an organized picture. One of the more interesting cases here is what's called reverse indexing. With authorization, we often want to run queries like, can Nikki access this feature? But we also want the reverse. We want to be able to ask whom can access these features. So for the product itself, it's more critical, the can X do Y, but for our management in the back office, for our security, for our compliance, we're also going to need that reverse indexing element. So there's a lot more to talk about here. Maybe I'll just add audit logs. So for customers, we want to see each customer to be able to see what they did in the application per their tenant. For the back office, we want to see what all our tenants did. And with microservices, multi-tenancy is almost a requirement from very early on. So these features with multi-tenancy are also going to be a requirement. So that's kind of covering the best practices 3 and 4. Lastly, GitOps. So in the end of the day, we want to manage our policy as code. That's kind of the standard. That's the trend. That's where things are going. And if we do that, we can get a lot of benefit from that because we can layer on top processes that are ready-made for managing versioning, managing the access control for the access control. Yeah, that's also something. There are recursive something that we need to be aware of. And we can apply tests both for the performance and the behavior itself. So there's no need to reinvent the wheel here. We want to work with policy and code and then manage it in something like Git and then apply GitOps on top of that. So merge code into our repository, do checks and balances, run unit tests as part of the deployment, manage who can change the code in the repository, do versioning. All of that is can be won rather easily, not cheaply, still requires effort, but easily by adopting this best practice.
So where does this programmable access control layer live?
So ideally, if you're building a product, it lives as part of your product, as a separate microservice with additional microservices layers on top to manage it. And there you basically have three options. You can either build a management layer yourself on top, ideally on top of open source. B, you can take open source, and there's also open source management layers, and I'll show one today, and you can leverage that as well. And there are services today, being frank, including my own, Permit.io, that you can adopt to manage all of this. And I think as long as you start with the best practices, you get to choose later without having to pay a lot for it. And that's, I think, the most important point. Don't build something that would lock you into, for example, we talked about the access control in the cloud itself, into something that is completely proprietary and doesn't allow you to evolve modularly. Something that is fully baked into your code, and then you're locked with that. So there are a lot of layers that for management we can put on top, internal, open source, or external. But the most important thing is to allow us to connect to those and not be coupled to anything that is unrelated.
All right.
So we covered our best practices. Now let's talk about, let's get to business. How can we actually implement this? So first of all, we need to understand that this space, while moving very quickly, is still maturing. Unlike authentication and identity management, which are rather mature and they're kind of like more, you should use JSON Web Tokens, that's a final answer. With authorization, things are still kind of evolving. The standards are still coming into fruition. And there are two camps that we can use for different options. And they have pros and cons. Let's cover them quickly. So on one side, we have our code policy agents. The concept there is very simple. We manage everything as code. We write code, usually in a proprietary language that is focused on permissions, access controls, and policies. And we manage that with an engine. In that engine runs that code. So we load code and data into the engine, and then we set queries to it. Code agents have the great benefit of being lightweight. It's just a Go application or a Rust application that we can run in whichever scale fits our needs, and they're tailored to be performant. On the other hand, they have a bit of a learning curve. These are not, so for example, we've got OPA, Open Policy Agent, with a language called Rego, and we've got OSO with a language called Polar. These are not your run-of-the-mill functional languages. They're not like Java or JavaScript or Python. These are logical languages. For those of you who are familiar with Prolog or Datalog, these are a derivative of those. Essentially, what the engine does is you write rules for it, and it runs recursively through those rules to find an answer. So it's different than what most developers are accustomed to, but still powerful tools and a great way to manage this. On the other end, we've got our permission graphs-based solutions. So when I say graphs, I mean edges and nodes as opposed to axes. And here, the road is really led by a white paper published by Google called Zanizabr on how they implemented access control for solutions like YouTube and Google Drive. But unfortunately, they didn't share any code. They just published a white paper. So that's a bit more challenging. But there are a couple of companies mentioned here that have started to develop an open source solution based on that. It's still not quite there. It's not it doesn't meet all the requirements of Google Zanzibar, but it's a start. And also with Zanzibar, it basically focuses you on REBAC, relationship-based access control. Those relationships translate into connections, edges between nodes on that graph. REBAC is a great policy, but it doesn't really do more advanced stuff. It's really hard to do attribute-based access control as opposed to the code-based CAM. But on the other end, we get to enjoy the reverse indexing. With code, we can run it one way, because that's the only way the code can run, and it's written to answer the question: does user X have access to Y? But and you can't run it the other way around. But in graphs, though, we can navigate on the graph on the other way, and that gives us that reverse indexing, or was also referred to in Zanzibar as the spice. So we have kind of pros and cons with those two camps. If you're building a small to mid-sized applications, or even a big one, but it's not like YouTube or Google size, you're probably better off running with code-based agents. They're both more mature and have cover more of your needs, and they'll focus more on performance, which is more critical for most companies. If you're like Google size, then something like Google Zanzibar is probably a better fit now. And I don't want to do too many spoilers, but I think in the end, as things evolve, we'll be seeing a combination of these capabilities that are kind of complementary coming together, and I'll talk about more in the end. So let's talk a bit about OPA, which is leading the charge for policy engines. So with OPA, we have our service, and that service would query the OPA agent, which would ideally reside as a sidecar next to the service. Why sidecar? First of all, because that really works well with a Kubernetes-like deployment. But in general, it focuses on performance. It reduces or eliminates network latency, because there's no going to a separate service, separate cluster, separate cloud to do that query. By the way, with most Google Zanzibar implementations, that's also kind of a downside. With OPA, we want to run this as a sidecar, whereas at most is a very close cluster. We load OPA with our policy in the form of Rego code, and our data is the form of JSON documents, and it's all stored in memory in OPA. OPA, in that sense, is essentially a glorified memcache. But it's a fancy glorified memcache that is actually good at what it does, and storing everything in memory gives you the advantage of performance. So you're not going to disk. So everything is in memory, essentially. Loopback adapter to in application memory, do a query, do a very efficient engine run if you structure your code correctly. And with that fashion, you can have your average OPA query be below 10 milliseconds, sometimes below 3 milliseconds if you structure the policies correctly. And that's really important, because we need to be aware that on average, every microservice would need 3 authorization queries. So if we start to pile up latency, it would basically kill our service. So that's really one of the benefits of working with OPA or a similar engine. Here you can see an example of how the code looks. It's not exactly like your run-of-the-mill code, as we mentioned before. We can see that you have 2 rules, and the engine will run for them in query. We can obviously have more rules than that.
Yeah, and I just dropped into the chat that the Open Policy Agent has a playground that allows you to kind of learn Rego interactively. Right. For those that are unfamiliar with Rego, because there is a learning curve here. It's totally exactly how Or said. It is not Python. It is not Java. It's a very different style of language. So it probably helps to hang out the playground for a little bit.
For sure. Also, one of the benefits of OPA being a CNCF project, and also having a very kind of open source project, is that there are communities. You can go in talking to other engineers, and you can ask them for help to learn Rego and get started, or learn Polar and get started. And you can also go to the permit community. And I also found myself more than once helping people just get their heads around Rigo. And you need to allow yourself to have the time to go through that, or at least find another solution to kind of manage Rigo for you. But it's a great tool, and it provides great performance, which I think is one of the main benefits that you need to just keep with the pace of your application. One of the challenges, though, with OPA is keeping it up to date with the application. So we already mentioned there's a distributed data plane from in the application itself and other sources that we need to work with. So we constantly need to feed JSON data, updated JSON data, and updated policies into OPA. We want, for example, we want our policies to come from Git, so we want to have CI/CD. So we have a new commit into Git with new policies. We want that to propagate quickly. And when we have our customers paying in Stripe, we want that information to arrive quickly. So that's a challenge. OPA was more kind of developed for running in Kubernetes and doing admission control. And so when you do infrastructure access control or admission control, you update this more as part of the deployment flow. But when you move to the application layer, things move more quickly. So now we need a solution to keep this real-time and event-driven. Remember, best practice too. So here comes another open source solution called OPAL, which, to be completely frank, I'm one of the contributors to and developer of. And what OPAL does is it makes OPA event-driven by using a stateless client-server architecture. So in addition to our OPA agent, we now have an OPAL client and OPAL server. Oh, by the way, OPAL stands for Open Policy Administration Layer. So it's an open source administration layer that you can use to manage your fleet of OPAs.
Is this similar to like installing this as the gatekeeper in Kubernetes? Is it like a similar kind of function there to trigger an event based on some change to something?
So gatekeeper would be using OPA. It's actually by default using OPA.
Yep.
And that's using OPA to kind of control how you manage your Kubernetes. But you need to feed OPA. So when you query OPA with gatekeeper or anything else, OPA needs to be aware of what's going on, what's the current situation in the world. This new pod that's connecting, is it supposed to be in or not? It doesn't know by itself. We need to give it the policy and data to make those decisions. So now the question becomes, how do we constantly feed that policy and data into the engine?
Got it. So OPAL helps you refine policies at will, and that trickles into the enforcement points without having to touch the Rigo code.
Exactly. So you can still touch the Rigo code, but you don't have to manually deploy it. So let's say we have this policy, we have this application. Let's say it's I don't know why I'm keep sticking to legal applications today, but let's say that's the case. And we have a lawyer connecting to the application. You know what? Let's shift this. We have an application controlling who can do deployments to our CI/CD. It's in Jenkins. So Jenkins actually queries this, for example. So this is Jenkins, and Jenkins sends a query to OPA, and he says, "Can I deploy this?" And as part of the query, it says, this is the user deploying. So now we need OPA to be aware of the list of users, for example, that are allowed to deploy, or the roles. And let's say we want as part of our policy that you have to be in the continental US to do a deployment now, because that's part of our FedRAMP requirement, for example. So we need to now translate the user to their geolocation. So, and we can now send a query as part of that flow and do that translation, but that can be very slow, and that will kind of encumber the entire process. Instead, what we can do is we can have OPAL know that this is a bit of information that OPA needs to have as part of the deployment that it's running on. So OPAL would subscribe through topics to the OPAL server, and it will receive updates to changes in both policy and data. So now let's, for example, have an event come into the server saying there's a new user and they're connected through this geolocation. For example, when they log in, we automatically get that geolocation. that will be sent through a PubSub channel, a WebSocket PubSub channel to the Opal client. It will go to IP info or MaxMind or our Salesforce or wherever we want to get that geolocation information, and drive that into OPA. When the user actually comes in and does a query, connects to the application, connects to Jenkins, and Jenkins sends a query on its behalf to OPA, OPA will already know if that user is allowed to do so or not, because it has the information on its geolocation already stored in.
I see. So the Opal client is receiving the PubSub information from the Opal server, which then talks to OPA. I mean, it's right in the diagram, but now that you said it, it kind of...
Yeah. And what's cool, by the way, is that the Opal client fetches the data by itself. The Opal server only sends the information on updates. It tells the Opal client where to get the data. So for example, if we have two clusters or two separate networks, the application here is probably using a database. Let's say we want the information from that database. There's no reason for the Opal server to access the database. We can block that through the firewall. But the Opal client, which resides in a sidecar next to it, can access it, and it accesses it directly and fetches the data into Opal. So there's a lot of flexibility in the Opal model to manage how we layer our authorization layer and how we control how it propagates data into our policy agents. And we can extend Opal with what we call data fetchers. We can teach it to bring data from databases and from LDAP and from Salesforce and Stripe and anywhere else. It's basically simple Python modules, two functions, fetch and process, that you write, and you can bring in additional data through the Opal client to Opal.
So to control access to the Opal server, that's all through Git PRs, correct? So that's how you control who can edit Opal policies.
So yeah, so Opal supports both Git repositories as a source for policy, and also HTTP web servers like bundle servers like OPA does. And so you can choose, but we highly advise and we recommend that you use Git repositories, because that way you have Git ops kind of off the bat. So you just tell Opal server, track this Git repository, and you cannot, and branch specifically, and you can have it track it with a webhook. So for example, with GitHub or Bitbucket, you can tell Bitbucket or GitHub to literally tell Opal, hey, there's a new policy, and that will be instantaneous. But you can also tell Opal to pull on your Git repository. But in the end of the day, what happens is you drive an update into the branch you selected Opal to track. Opal will track the differences in that and propagate those as updates to the Opal clients that subscribe to them. So we didn't really go into this, but Opal allows topics. So you can have different clients. So let's say I have two microservices, one for billing and one for analytics. They have different access control. They have different policies and different data that they need for that. So each of them can subscribe to different policies through Opal by just configuration. And then the repository can have different rego files and different folders, and the folders themselves and the repository would translate into the topics. So I just update a different folder that translates into a Git update, a Git push, and that translates into an Opal event that trickles down into the different services, and you can have multiple services subscribing to multiple topics on multiple tenants, etc., etc. Those topics are also a good way to apply multi-tenancy. So we can have a prefix or just a separate topic per tenant, and then each Opal and OPA instance has a different world picture according to a tenant. And you can, and this is generic, right? You can use those topics to mix and match this. And this, by the way, also works with also other event-driven solutions and message queues. So for example, with Kafka, you can have Opal subscribe to Kafka. So you have topics within topics. I won't go too much into that now, but you can, if you are managing events in your organization with Kafka or with Redis, Opal supports them off the bat. You just tell them, hey, listen on this event or topic within Kafka, and then you can trigger updates through Kafka itself, or Redis, or Postgres, this and Notify, etc.
And this is where different cloud providers come in, because you could just ship this to wherever an Opal client is, right? It could be in any one of the cloud providers anywhere, really.
Right. Yeah. And so you can have the Opal servers on a different cloud and the Opal client on a different cloud, but it will all sync together through that really efficient WebSocket channel. So everything is really driven to be updated as quickly as possible. The reason for that, by the way, is to maintain everything as consistent as possible. So with Opal, you want to know that the policy or data is changed even before you know what the change is. So changes are really, really fast, and there's a separate channel for actually receiving the data itself. And you can, by the way, you can bake in policy to also take into account if the picture is stale or inconsistent. I can talk for hours just on that, just on conflict resolution.
Let's see how this works.
Yeah, but let's dive in. So let's do a quick demo now of Opal, and we'll see how we can update both policy and data, and see how easy it is to get started. Let's jump into the demo. So the easiest way to start is just going to permit.io/opal on GitHub. You can take our Docker Compose and just start that. There's a line there. It will just download the Docker Compose and set up an example app with both the Opal server and client. So Opal will now be tracking Git Repository. We set it as example. And we'll use that to kind of set up the application. So we'll just be running that. And we already have Opal here running in the background with both the server and client. And it's fetching the data directly from that Git repository. And it has the relevant picture. Let's see the data is that already propagated from the Opal server to the Opal client to the OPA instance. So this is querying Opal directly. Opal doesn't abstract Opal for you. It gives you access to it. So we can see the data in Opal itself, in OPA itself, by querying it on port 8181. And we have the world picture here with users and their geolocation, IP, and actually the country. So for example, Bob is located in the US. He has the role of employer and billing. Now let's see if Bob can read the finance object that we've defined. So we do a query to OPA and we get the result true, meaning that Bob can. Now let's tweak this. So Bob can do this because the policy says that geolocation is allowed to do so. But now let's update Opal with a change to its geolocation and see that happening live. So we're installing the CLI tool that allows us to manage Opal and OPA quickly, and we can trigger updates through it. There's also an API, and we can do it through Kafka, as I mentioned before, but the CLI tool is a fun way, easy way to get started. So we're installing so it's a Python package. We're installing it. It's pretty quick. So we did pip install Opal client. So the client also includes the CLI. And we'll just give it a second to kind of install. And once we have it ready, we're going to trigger an update event. It will be sent to the Opal server. Through it as an instruction to the Opal client. The Opal client then will fetch the data source directly, which is going to be the solution country.is, API.country.is. And we're giving it the IP address of the user, and we will get the geolocation as a result of that. So we are querying the geolocation from a third-party service. We ran this, and we can see that the update event actually happened in Opal. And it actually was sent to the client, and the client actually fetched the data. And we can actually see that the data would reside now in the OPA instance. And we can check if Bob can access it now that he basically switched locations. So we do the same queries before. We're querying OPA directly. But now we get the result false because the policy requires Bob to be in the US, and he is no longer there. So he can't use that feature now. Now let's check something else. Let's see how we can create policy to allow specific things. Let's say we have an entity called bird. Let's see if Bob can read it. So Bob currently can read bird. And let's look at the policy and see why is that. So we're going to the policy itself, and then we'll change the policy, the code itself that defines that, and push it into an updated Git to allow that to happen. So if we look at the policy, we'll see that there's like a direct rule for that. We can see that Bob can't access anything, but now we'll add a policy saying that if it's Bob, he can always access. Just for as an example. So we added that as code, and while we're just pushing that, git diff into our Rego code as part of the repository. And that will affect OPAL immediately. So we do a commit and push. And now we configured this with polling. If it was with a webhook, it would be instantaneous. But this demo is with polling, so it will take it a couple of seconds until OPAL polls at the repository again, identifies the update, and then propagates the change. So we got the update, we propagated, and it was sent to the clients. And now when we go to the OPAL client and OPA instance again, and we do the query, we'll see that now Bob can basically access anything because that's what the policy says. By the way, not a policy I'd recommend having, but super user is pretty common. And the key here is about ease of use. We've connected this in a couple of minutes to both our Git repository and an external data source. And all we did was a couple of CLI commands and editing one Rego file. So working with OPAL can be very quick and can take you to a far more advanced level of working with OPA and policy as code in general. By the way, if you go to OPAL.ac, there's another demo there. By the way, this demo is also available, and this entire deck will be available to you, so you can view it later. But on OPAL.ac, there's also a demo of connecting this with an UI. So if you want to, for example, be able to change policies as part of a UI or assign roles as part of UI, you have that demo, and it's also something that's obviously available as part of Permit.io.
So question. Yeah. So just walk me through how this works again. So let's just say you have a Node app, right? And you're trying to layer on top of that the OPAL client so that it can ingest information from the OPAL policy server. How do you connect that? Like, random web apps.
Yeah. So that Node microservice would be running with a sidecar or with another service next to it that would be containing OPA and OPAL. And when he wants to run queries, so at the beginning, it would query that OPA instance running next to it. So you'll have something like, if you use Permit.io, for example, we wrap this nicely into permit.check. And so you do if permit.check user can perform action, that translates into an OPA query. And that's all the entire policy code that you have in your Node service is that if permit or your SDK.check. That's it.
And it has to be as a sidecar, or could it be as another microservice that gets queried?
So it can be another microservice, can be a cluster. We can also talk about managing a complex data picture. Like if you have, most companies would have a world picture of a couple hundred megabytes, a few gigabytes that you can replicate easily into OPA. When you get into multiple gigabytes or terabytes, that's where doing sharding with OPAL, that's another feature that OPAL adds, the ability to split data randomly or by topic between multiple OPA agents. That's when you run this as a cluster, for example, and you can do that. But for most applications, it's ideal to just run this as a sidecar or a near application so you can enjoy the low network latency. Ideally, your microservice and OPA would be talking to one another through the loopback adapter. So there will be no network latency.
Got it. So the sidecar is really around performance.
Completely. That's the reason number one. So So it's separating it from the application itself in an easy way, and then enabling the application to connect to it in an easy and performant way. So now when we have, by the way, so I talked about connecting our code directly to OPA through an SDK. We can also put it as a middleware, as a decorator. We can put it also as a reverse proxy. We can have an Envoy plugin, for example, querying OPA for us according to the URL. We can put an API gateway to talk to OPA for us. but the concept remains the same. Just be a sidecar next to that reverse proxy or API gateway or middleware solution. So now we covered where we have our microservice. We have a sidecar next to it with OPA and OPAL. OPAL, what it does, it stays next to OPA and just keeps it up to date. You can then configure OPAL through the OPAL server to connect to multiple data sources and policy sources, multiple Git repositories, multiple services, and you just configure it and say, this is where you get your data. And the OPAL client will listen in, and every time something changes, it will bring that to the service into OPA, and when the query comes, it will be ready to answer it. So what's important to understand is this is decoupled, and this so the updates are happening asynchronously in the background and not part of every query. That also contributes significantly to performance and scale. And yeah, so that just works kind of out of the box with OPAL, both the Git repositories and multiple data sources, and doing it in scale.
Cool. This looks like a really exciting project here. I'm just poking around on GitHub.
Yeah.
What's it like being a co-maintainer? Is there a lot of...
It's super fun. So also it's a rather young project. It's not even a year old. It's already deployed in production in Tesla, Accenture, Zapier, a couple really awesome companies, and a lot of other companies. Some of them we're not even aware of because it's open source, and we only know about the guys coming in yelling and asking for more features. And there's the Slack community and our GitHub, and people constantly coming in and asking questions and talking about this stuff. And it's just, for me, it's super fun just working with other engineers and getting excited about how we can build this better for the future and adding more features. It's just fun.
Yeah, and it looks like there's a pretty cool Docker Compose playground to get started with this. So
yeah, it's basically that one-liner I showed before. It also comes with YouTube videos and walkthrough in the GitHub is a how-to file. You could just go through it step by step to get going. And obviously, if you have questions, you can just hop on our Slack, and me, Asaf, or some other folks from the team would be happy to help you, as we already do with a lot of others.
Cool. So just, are there any areas of OPAL that you need contributors to, just that you have our audience's attention?
There's a bunch. So people have been adding data fetchers, for example. So there's a Postgres data fetcher and a Stripe data fetcher and an LDAP data fetcher. There's so many other sources that people want to connect to. And those are like the perfect place to start, just writing a simple solution that connects to another data source. There's always demand for those. There's also on our GitHub issues, there are issues marked as a good place to start, as a good first issue. We're really excited about anyone who wants to kind of contribute. And there's also a lot more going into expanding this kind of suite of solutions. So we have another open source project that we haven't actually announced. It's still kind of coming into fruition, but the idea there is to use OPA in your front end. So obviously in the back end, you want to shut the door firmly on anyone who's not supposed to do something. In the front end, you want to adjust the experience. You want to show them something else instead of what they can do. And it's really hard to do. Like, will we be sending OPA queries from the front end to the back end? That's really cumbersome. So we have an open source solution called Optoggles that's coming out soon that does that. And we're also looking for contributors around that part. And that's even earlier and even more looking for offering.
Cool. I just want to get to one question that came up earlier in the discussion. It was by a user, Sekunoid. I think I said that right. Okay. Will you be talking about machine-to-machine authentication authorization? So I guess, does OPAL, or in this access control layer, can you implement this in a machine-to-machine kind of way?
Completely. So it's essentially transparent to OPA and OPAL. So in the end of the day, you write policy in a completely generic language in Rego, which is Turing complete. You can describe anything you want. You need to maybe put a bit of effort to make sure it's performant, but you can describe wherever you want. And you can have that policy deal with both human users and artificial identities. And there are two features here that are very common that we want to be aware of. One is in the authentication layer. So that's assigning developer tokens and assigning and using also maybe JSON web tokens as the identity. And then on top of that, when we provide the application to our developers in the authorization layer, we want to create a API key management solution. So for example, with Permit.io, that's something you get out of the box, but with OPAL and OPAL, you can build it on your own. And the idea there is, at the end of the day, you're creating cryptographically good tokens. You manage their association to non-human entities, and you can apply things like revoking and assigning them to specific software segments or microservices. And it just translates into more policies that you want to write and interfaces that are tailored to the non-human experience, or more correctly, the developer creating that experience on top. But on the underlying infrastructure part for OPAL and OPAL, it doesn't matter at all if it's human or not. It's just a different policy.
Or we have another question here related to non-human experiences. Linux Girl asked, can you provide guidance for service accounts that are used for multiple purposes or shared across multiple resources?
Sure. So there are multiple layers of hierarchy that are very common. The first one is multi-tenancy. So you want to separate your organization, your kind of world picture into the different tenants or different end customers. That's usually ground one. And for multi-tenancy, there are two levels of separations that you need. One is in the policy, in the application behavior as we're describing now, and the other one is in the storage layer or data layer. If you have those two, and the application layer, I'd say it's 80%, like in the data layer, it's basically having a separate table, separate column, something like that. So if you have those two, you're good to go with multi-tenancy. And then per application, you have a lot of times often more logical silos that you need to have. Organizational groups or different applications or silos. And then there's not really generic advice that I can give. It's like if someone wants me to help with that, we can like sit down for coffee or over Zoom and kind of talk about the architecture. But it will be very similar. It's about recognizing where you have that difference in the policy and in the data storage, and creating interfaces on top of that. I can maybe give an example, like with Permit.io. What we did is we created two boxes in addition to tenancy. So tenant is a silo that contains users and their affiliated automated entities. And next to it, in a parallel fashion, we have what we call projects. Each project is an application the user would be developing. For each project, you'll be getting, for each project, you have an environment. So you can have dev, staging, production. And for each environment, you'll have a separate API key. That separate API key basically plugs into the automated non-human entity. And that also gives it both a combination of its identity and its derivative into permissions. Within the interface itself, you can then roll that key, you can revoke that key, and you can assign different permissions to it. So you have a separate layer for identifying and then another layer to connect roles to it. And in the policy, we create kind of logical silos to allow the humans working with this to divide this into their right building blocks and things that they're working with. And in the end of the day, it's also based on OPA and OPAL.
Cool. We have
talk about that.
There's one more question in the chat. What type of auditing from Ray Arts? What type of auditing or logging capability does OPAL have?
So a lot of it comes with the decision logs for OPA itself. So OPA creates, I think it's one of its main benefits, I'd say actually. OPA creates really detailed decision logs on each query that it provides. And those include what version of code it's running, what actual code ran, samples of the relevant data that was used as part of the query, also benchmarks. And those are completely exportable from OPA through OPAL to wherever you want. So OPAL kind of exposes direct access to OPA and also gives you kind of easy management solutions to manage OPA at scale. So first of all, that main layer of decision making, it's managed by OPA, and OPAL exposes it as well as we can. On top of that, there's also the data propagation element, and OPAL provides really detailed logs on every event that happens. Again, it's an event-driven solution. So you can get those logs themselves and use that to kind of track what changed throughout time. This is the point where a new update was pushed. This is a new layer. This is where a policy was changed, etc., etc. And you can also listen into OPAL. So you can have Kafka connected, or you can have another. You can have an OPAL client just to create an event stream to listen to. So you can listen live to events happening and make decisions according to that, and connect it to your SIEM-SOC. You connect that to your management solution. You connect that to Slack just to get notifications of things that are happening. And you can use OPA to filter events coming from OPAL. And you can update the OPA filtering OPAL with OPAL. There are a lot of sessions here that it's just fun, but can be confusing, to be honest. Lastly, OPAL also provides health checks and transactions. That really connects to the consistency issue I described before. So there's a point where an event comes. OPAL knows that the policy needs to change in these clients, and it's going to send an update to them. But it will take time for the client to receive the update and apply the actual data change. So OPAL allows you to track those changes. You can query the OPA agent with a special policy, letting you know what's the state of each agent. And you can get each OPAL client to call back to you, letting you know when it completed an update. And that can also translate into another event in the event stream. So there are really multiple ways, both asynchronous and synchronous, where you can use OPAL to kind of create auditing and logging for this entire thing in a really performant way. We really put a lot of thought into having those updates and propagation of them and tracking them as efficient as possible. There's actually a little more, but I think I've rambled on this question, so I'll pause and let maybe answer other questions.
Sure. I think we're out of questions here. So if you want to kind of wrap this up with, takeaways for the audience or any other sort of concluding thoughts here.
Yeah, so I'll just run through this quickly. So we have,
sure.
So we in the end of the day, we need to understand when we're building AccessControl, we need a full stack solution. We need infrastructure, interfaces, and APIs and experiences for both ourselves and our customers. And I just wanted to give the example here. It's not just on the back end, it's in the front end, and not just the front end itself, but the back office front end that is managing this, and low code interfaces for the guys at AppSec, and low code interfaces for the guys at product. There's a lot going on here. You don't need to have all of those at day one, but you can. And you probably will need some of them as you move forward. And that's really the area that we focus on with Permit.io. And lastly, because I hinted on it before, I already said that this space is kind of still nascent. It's still evolving. We still, as humanity, we haven't decided what's the best way to work with all cases or the average case. Should it be code-based, graph-based? And we kind of touched on their pros and cons. What really stands out for me is that those pros and cons are complementary. The policy code engines are highly performant, but very strict to the point. The graph solutions are not that performant and suffer from latency issues, but they give you a really full picture and that you can query in greater detail and in multiple directions. I really think that the future will be hybrid. I think we'll have a big graph in the cloud for the authorization layer and distilled data pictures from that graph in code agents at the edge. That's what I think. It's still early to tell, but I think that's the area that we're evolving. But I think the main lesson here is it's evolving. So when you're building a solution, you need to be aware that the best practices that you work with now are good, but more things might be added. And if you want the real best practices, that's about preparing yourself for that evolution. So be aware that things are going to change, and you'll be able to leverage those connectivities when things change. And there are two main recommendations here. Either take a full solution that will do this for you. So as things evolve, the solution, that service will just provide for you. And the other one is being as event-driven as possible. Through it being event-driven, you'll be able to latch on. For example, when there's this graph in the cloud, when you get it from another vendor, you can latch onto it through something like OPAL, for example. And that will enable you to keep up with the times as things are evolving.
Nice.
I'm sorry that's not a full answer for how to be prepared for the future, but I think it's a good start.
Or it looks like we have another question from Drum Boots. Is there any reason to still consider XACML/ALFA versus these new solutions?
So first of all, I think those are great solutions. I think you can work with them, but I think there's you need to kind of differentiate between the concepts and implementation. Honestly, I wouldn't take any solution that it was implemented in the 2000s or earlier and just take it as is and plug it in. It will probably not be scalable enough for you just because of its architecture and design. It's an okay place to start, but it will probably also force you to couple more things that you probably should. That being said, a lot of the concepts that exist there, especially in AccessControl, I think translate very well into these modern solutions. I'll give a concrete example with OPA and OPAL. So you have three kind of, I won't explain for all ACMO now, but just kind of three highlights. So you have your policy enforcement point, you have your policy administration point, and you have your policy decision point. Your policy enforcement point is where and this is like pure XACML, right? So your policy enforcement point is where you actually check for permissions. That would be the SDK in the code that we mentioned, or that plugin for Envoy, or your plugin for API gateway. That's your policy enforcement point. Your policy decision point would be OPA. So OPA is a decision engine that those enforcement points can query. And that's literally it. And in a very non-surprising fashion, your policy administration point would be OPAL. So the OPAL server and things that you layer on top of it would become your management layer, administration layer, and that will propagate into your decision points and into your enforcement points. So XACML as a concept is still alive and kicking. As core implementations from the day that it was invented, not as much. Hope that answers the question.
Yeah, or thank you so much. This has been super informative. I am new to this field, and I actually work on identity access management solutions. So this is super, super informative for me, and I'm sure it was for the audience as well. I thank you again for being here with us. I think we are running close to out of time, so if anybody has more questions or it looks like you had your Calendly up for a second, right?
Yeah. So as you can tell, I'm always super excited to talk with fellow developers and security people. So you can reach out to me. You'll find me anywhere as ORWEIS on Twitter, LinkedIn, GitHub, wherever. And you can just schedule a Zoom call with me, or the easiest is probably going into our Slack community, just shooting me a Slack message. You'll find that I'm highly responsive and always excited to help.
Nice, thank you. And you guys can also, sorry, go ahead.
No, just thank you.
Yeah, you guys can find this information in the bio, including our DevSlop Twitter and YouTube. You'll also see the recording of today's show in the bio, and you can follow Nikki, you can follow me, you can follow Nancy, our producer, for more updates. Next weekend, we have an exciting show with Paul Ionescu, and he's going to talk about software security education with the OWASP Securing Coding Dojo. And on Friday, March 18th, we are going to have Samantha Floriani talking to us about how to avoid a privacy disaster. So yeah, great shows lined up for you. Again, you can find recordings of previous shows, including today's show, on the DevSlop YouTube. And if you have any questions for Orr, again, you can reach out to him on his Slack for the OPAL project. So you can schedule a coffee chat, or I think I'm definitely going to grab some time with you to learn more about this stuff. Yeah. So thank you again for joining us.
My pleasure.
Thank you, Orr.
Thank you, Nikki. Thank you, Sri. Look forward to staying in touch.
Yeah, thank you all.